The interquartile range is a value that we can use to represent how spread apart or how close together data values are in a data set. To find the interquartile range, all we need to do is find the difference between the third and the first quartile. So our IQR, interquartile range, can be found by taking the third quartile and subtracting the first quartile from it. Essentially, the IQR tells us how long the box is in our box plot. IQR is very useful for determining if we have outliers in our data set. So if we can take a look at the IQR and copy it 1.5 times to the left of the box, we can create what I'll call a fence. Let's call this the left fence. That tells us if a data value is normal compared to the rest of the data, or if it's considered an outlier. For example, here we can see there's a little asterisk to the left of our left fence, meaning it's so far extreme on the left side of our data set that it's not really considered normal or part of the group. We can do the same thing on the right side, where we copy the length of the box 1.5 times to the right. That will allow us to draw a right fence. This right fence is going to tell us if we have any data values that are extreme on the right-hand side, larger than everything else in our data set. We'll use the left fence and the right fence to help us determine if any values in our data set are extreme, if they're outliers. To find our left fence, I need to start with the left edge of my box in the box plot. That comes from Q1. Then I'll subtract 1.5 times the length of the box, which is the same thing as the IQR. So our left fence is Q1 minus 1.5 times the IQR. The right fence can be found in a similar fashion. Start with the right edge of our box, which is determined by Q3, and then this time we'll add 1.5 times the length of our box. So the right fence is Q3 plus 1.5 times the IQR. Notice that these calculations are similar but a little bit different. For the left fence, we need the first quartile and then subtract to go further left. For the right fence, we need the third quartile and then we add to go further to the right. Let's take a look at an example where we calculate the left and right fence and then use them to determine if we have any outliers. In order to calculate the left and the right fence, I need to know my IQR. And in order to know my IQR, I need to know my first and my third quartiles. We know how to find these by hand, but we can also find them on our calculator. So what I'll do is enter in this data set into my calculator and find my 5-number summary. Now that we have our 5-number summary, we are able to calculate the IQR using Q3 minus Q1. Now we have everything that we need to be able to calculate the left and the right fence. For the left fence, I'll start with my first quartile, which is 308,750. Then I'll subtract 1.5 times my IQR, which is 340,250. For the left fence, we actually get a negative number, which means in order for us to have an outlier on the minimum side, we would have to have a negative number. And now looking at the context of this data, this is real estate prices. So having a negative number for a real estate price, it essentially means someone's paying you to take it. Not realistic, but also we don't have a number smaller than this left fence, so we know that there's no minimum extreme value. Let's take a look on the maximum side. So let's calculate our right fence using our third quartile plus 1.5 times our IQR, we find that the right fence exists at 1,159,375. We actually do have a data value that's larger than this. Notice that the 1,095,000 is not larger than our right fence, so that's not considered an outlier. But the 5,500,000 is, so we have an outlier. Because that data value is greater than our right fence, we have an extreme value, we have an outlier. Determining outliers is useful sometimes because we can credit the outlier to some kind of mistake in the data, and we can omit that data value. But that's not always true. Just because you have an extreme value doesn't mean that it was a mistake. And if you don't recognize that there's a mistake behind that extreme value, you might want to explain why it is extreme. What caused that extreme value to be so extreme? For example, in these real estate prices, having a $5.5 million piece of property, maybe it has lots of acreage, or maybe it has a subdivision on it, or maybe it has an apartment complex on it. So there's got to be a reason why that extreme value is so extreme, or maybe it was a mistake in recording the data.